Now we'll take up sliding or kinetic friction in detail. About kinetic friction, as the name implies, we can write it is the friction force acting on a moving body, obviously on rough surface. When a body is moving on a rough surface, the friction force acting on it is called as kinetic friction. And we can also write that it is equal to the external force required to move body at uniform speed. You know that when unbalanced forces act on a body, the net force will be F1 minus F2 if these are in opposite direction, and due to the force, the speed of body either increases or decreases. Here we can understand the concept which I have written over here with the help of a situation. Say this is a rough surface on which a body is moving at a speed v. Now in this situation, if it is moving forward at a speed v, the friction will act on it in the direction opposite to the speed, and this friction we denote by Fk because it is kinetic friction as body is in motion. Now due to this friction, the speed will slow down. Now if we apply an external force onto the body, so that external force is exactly equal to the kinetic friction, and if the body is moving, then the speed will not increase or decrease. Speed will increase if F external is more than kinetic friction. Speed will decrease if kinetic friction is more than F external, because if the net force acting on body, here net force we can write as the two forces are in opposite direction, F external minus Fk. So if external force is toward right, F external is more, speed will increase as the net force is in the direction of a speed. If kinetic friction is more, this value will be negative, or net force will be Fk minus F external, that is in backward direction, and as it is opposite to the speed, so speed will decrease. But here, if body is moving at uniform speed v, that means speed is not changing. This implies the net external force is equal to 0, or this gives us the kinetic friction which is equals to F external. This is what I have written over here. You can read it out once again, that it is kinetic friction is equal to the external force required to move body at uniform speed. One more point here you can write that as during motion interlocks between irregularities of surfaces are not complete, because when the body is at rest, the interlocks does not allow the body to move, or the friction when the body is at rest will be more, because the interlocks are complete. The hills and valleys of the two surfaces interlock into each other, but when the body is moving, interlocks are not complete. This implies kinetic friction is less than maximum static friction. Maximum static friction is the limiting friction up to which the body can be kept at rest. So you should always keep in mind that the value of kinetic friction is less than the limiting friction or maximum static friction up to which the body is at rest. And this because during motion the interlocks are not complete, or relatively less number of interlocks are there when the body is in motion on a surface. So always remember that kinetic friction is always less than limiting or the maximum value of the static friction.